This meeting is being recorded.
In this next video, I'd like to clarify something at the end of section 5.1. So the last video ended on this slide here, but I wanted to continue with the last slide. I found an error on the answer slide, so that has been corrected and a new PowerPoint has been uploaded. But let's review this last section here in this video. So we're asked to determine whether or not we have a cis trans, isomer, or neither. So let's see if we can do this. Let's take a look at these structures. And we know that based on either a double bond or a ring, if we have our priority groups on the same side, we would call it cis. If they're on opposite sides, we would call the structure trans. And then we'll see when we can call it neither. So in our first structure, say we draw our dividing line for our plane here, for our double bond, we draw in our hydrogens. We see that our two highest priority groups on those carbons are vinylic positions. These two carbons are on the same side, so we call this a cis isomer. Let's see with the similar structure down here. This is the trans orientation. So again, we have a hydrogen here, a hydrogen there. We draw our line to separate our planes, and we can see that our two highest groups are on opposite sides of our double bond. In this middle structure here, if we were to kind of draw the plane to separate above and below the ring, we would see that even though this substituent's in an axial position and this one's in an equatorial position, they're still on the same side of the ring. So this we will call cis as well. This guy up here, this will be a trans orientation. So if we were to kind of draw our dividing line between the top and the bottom of the ring, we would see that both of these are in axial positions and one's on the top of the ring, one's below. This last structure down here, we would say is neither because at our vinylic positions, we have more than a di-substituted alkene. So when we have a tri or higher, a tetra-substituted alkene, we use a different naming system and we'll learn either E or Z nomenclature for tri and tetra substituted alkenes. So this one, for our purposes, we cannot call either cis nor trans. So we will continue with the next section in our next video.